earlier group elements which are present in that. Okay, we are writing the electronic configuration, and then after okay, so 38 boron, aluminum, gallium, indium, and thallium are those are present. The general electronic configuration of these 38 group elements is ns2 np1. Okay, the differentiating electron is entered into the p orbital. That's why 38 group elements are called as a p block elements. We are writing the electronic configuration. From that electronic configuration, we are able to understand that one. It is a common oxidation state is +3. Okay, that is enough for the examination point of view. Next, we have to discuss about the next is you are writing about the important minerals of boron and aluminum. I already told that the important minerals of the boron and aluminum are borax is the important one. That is Na2B4O7 10H2O is the borax. Okay. Next is the you are having of that one. Aluminum is there. Aluminum, the bauxite ore, cryolite, and feldspar. These are the important minerals which are present in that one. You have to study those elements, right? Next is the boron hydrate. Boron hydrates are classified. Boron hydrates are classified into BnHn plus 6 and BnHn plus 4 type. Boron hydrates are there. Those boron hydrates they are classified in that BnHn plus 4 boron hydrate is having of the diboron is the best example. That is a boron hydrate BnHn plus 4 and BnHn plus 6 is type also boron hydrates are possible. Next is the oxides. Those oxides are which are having of the oxides. Boron trioxides are formed. That means 30 group elements can form the oxides. Those oxides are boron trioxide. Suppose B2O3. When you are thermal decomposition of boric acid, you are getting of the boron trioxide. Boron trioxide is acidic in nature. And aluminum. So aluminum hydroxide. When you are aluminum trioxide has formation. When the aluminum is reacts with the oxygen, formation of aluminum trioxide, Al2O3. This aluminum hydroxide is act as amphoteric in nature. Boron trioxide is act as a acidic in nature, and aluminum trioxide is act as a amphoteric in nature. So amphoteric means they can act as a acid as well as a base. That is called as amphoteric nature. Sometimes it acts as acid, sometimes it acts as a base also. Okay. So that is about the aluminum oxide. Similar manner, gallium oxide also same property will showing up. Next, thallium oxide and indium oxide is the thallium oxide and indium oxide is the basic in nature. That we have to learn that. Next is we are already the question is important question. What is the electronic deficient compound? Electron deficient compound also we have discussed that one. That means the central atom is having of the whatever the number of electrons is less than the bond formation. The compound in which the number of valency electrons of the central atom is less than the stable valency electrons. That is called as a electron deficient compound. Suppose if you are taking the example of electron deficient compound is diboron, B2S6, that B2S6 boron is having of the only 12 electrons are there. But the formation of the bond, that boron requiring of 14 electrons. There's a 2 electrons are less, even though the diboron is a stable compound. So formation of the diboron is you are getting of the stable compound is formed. Diboron is the stable compound. So that is called as that one. Okay. So why? Because we are comparing with the ethane C2S6. It is a B2S6. That's all. Only the difference between But C2H6 we are having of the 14 electrons. In the B2H6 we are having of the only 2 electrons are present. That is a important one. Okay. So now I am reading of the questions are important questions in that case. Write the electronic configuration of 30 group elements. First question. Write the hydrides and oxides of the boron and aluminum. Why? Because hydrides of the boron are classified into BnHn plus 4 type, BnHn plus 6 type. These are the two categories of the diboranes are present. Okay, boron hydrides are there. Oxides are boron, that means trioxides are formed when it is reacted with the oxygen. So oxides in that boron trioxide is the acidic one. Aluminum and gallium trioxides are amphoteric in nature. Thallium and indium trioxides are basic in nature. Next is what is electron deficient compound and give an example. I already told that the electron deficient compound is nothing but the number of valency electron required for the central atom to getting of the stable compound, that is less than the valency electrons are present in that compound, that is called as a electron deficient compound. Example is diborane. Next is the preparation and properties of diborane. It is a essay type question. In your examination point of view, essay type question, you have to say that one. What is the write the preparation and properties of the diborane? You have to write that one. So electron deficient compound in the preparation is the diborane is the preparation will be there. So in this case, the preparation you have to write the 3 preparations and as well as the 3 properties will be there. You have to take about the 3 preparation, 3 properties. This is the essay type question. And discuss the structure of diborane. The next question is discuss the structure of diborane. Why? Because diborane is the electron deficient compound. In that electron deficient compound, this electron deficient compound, we are having of the minimum number of valence electron is requiring of diborane is requiring of 14 electrons. But in the diborane, we are having of only 12 electrons are present. Due to that, that compound is called as electron deficient compound. So we have to prepare and properties. The structure, main structure is how can you bond between the central atom? Borons, 2 boron atoms are there. The 2 boron atoms are how they are combining with one. So in between the a bond is does not there. A bond does not present. So that between the boron and boron, you are not having a bond. So due to that reason, you are having of that a bridge-like structure is present. That is a bridge-like structure is proposed that the SIDPIC. So you are having of the diborane is a bridge-like structure or banana dialectic structure. That is the question of the discuss the structure of the diborane. You have to elaborate this diborane structure, the banana structure, and also bridge-like structure. You have to elaborate. Next, last question in this chapter is what are aluminum alkyls? Just like boron alkyls, we are having of the aluminum alkyls are present. Boron alkyls, aluminum alkyls is there. So you have to write the aluminum alkyls. Okay. Next lesson is the 4th A group elements. Ultimately, that is nothing but write the electronic configuration of 4th A group element. That is the question. So what are the 4th A group elements? That means carbon. We are having of the carbon, silicon, germanium, tin and lead. These are the 4th A group elements. Carbon, silicon, germanium, tin and lead are the 4th A group elements. We have to write the electronic configuration for that 4th A group elements. Okay. By that, we are getting of the some important information regarding of the 4th A group elements. Next, we are having of in the 4th A group elements. Why? Because oxides are there and hydrides are there. Hydrides are just like the hydrocarbons. We are giving of the hydrocarbons. Those hydrocarbons are just like the carbon hydrides. the carbon hydrates, and next is you are having of the silicon hydrates. Carbon hydrate and silicon hydrate will be there. Next, we are having the oxides. Monoxides are there, dioxides are there. Monoxides, how they form means already I told that incompletely burning of the carbon or silicon. You are getting of the carbon monoxide, silicon monoxide. Those are very dangerous. Carbon monoxide is the primary air pollutant, which is a primary oil pollutant getting of that one. So it is a most effective for the atmosphere. Next is the dioxide, sir, carbon dioxide as well as that means carbon is when completely combustion. When carbon completely combustion, you are getting of the carbon dioxide, and silicon will combustion with the oxygen, you are getting of the silicon dioxide. Actually, the silicon dioxide formation of silicon monoxide with the silica. When you are excess amount of that one, you are burning up, that means completely burning of the silica. That means silicon Si is burning on the oxygen. In presence of oxygen, formation of the silicon dioxide. Here the main question is why at the room temperature carbon dioxide is a gas and silicon dioxide is a solid at room temperature. They are asking the every time question. It is a very important question. Why is carbon dioxide is a gas while silicon dioxide is a solid at room temperature? Explain it. The simple reason is here. Carbon dioxide is a gas at room temperature. We know that. Why it is? Because of it is a discrete molecule. A discrete molecule having of the carbon between the carbon, there is a two double bonds are present. The central atom of the carbon is both sides we are having of the two double bonds linked with the oxygen. It is a discrete molecule and a linear structure making of the bond angle is 180 degrees. So that the carbon dioxide is existing in the atmosphere as a gas state. But in the case of the silicon dioxide is a three-dimensional structure tetrahedral bonded by the oxygen, 4 oxygen atoms. The silica is bonded by the 4 oxygen atoms in tetrahedrally. So that the tetrahedrally bonded means it is a three-dimensional one. So it is a solid nature in a at room temperature. That is important of the carbon dioxide and silicon dioxide. Okay, so you can understand that one. Next is the classification of that one. We are having of the carbides. When the fourth A group elements are classified into different categories: carbides, carbonyls, silicates, silicones. These are the classification of their carbides. Carbides are binary compounds of carbon atom. Binary compounds of carbon atom. Those carbides. These carbides are carbon carbides are classified into ionic carbide, covalent carbide, and metallic carbide. Ionic carbides. Ionic carbide is nothing but the examples of aluminum carbide, calcium carbide, magnesium carbide. Like these, the carbides are called as ionic carbide. Covalent carbide is nothing but we are having of the covalent carbide is there. Silicon carbide is a covalent carbide. Okay. And metallic carbide means tungsten carbide. Tungsten is a metal which is linked with the carbon is tungsten carbide. Those are present in that one. Okay. These are the classification we have to write. It is a 10 marks question. So that what are the carbides, how they are classified, give example of each category. So carbides are nothing but binary compounds of carbon. And these are classified into 3 categories: ionic carbides, covalent, and metallic. These metallic carbides also called as interstitial carbides. Okay. Examples are given. Ionic carbide is magnesium carbide, aluminum carbide, calcium carbide. Okay. Here all are example. These are when these carbides are hydrolyzed, we are getting off the hydrocarbons. When the aluminum carbide is hydrolyzed, we are getting off the methane. When calcium carbide is hydrolyzed, we are getting off ethylene gas. Like that, you are preparing from the carbides. From these are the ionic carbide. And the metallic carbide means, sorry, a covalent carbon, silicon carbide is there. Okay, these are the covalent carbide. And metallic carbide is tungsten carbide, right? Next is the carbonyls. You are having of unimolecular carbonyls, bimolecular carbonyls. Unimolecular means the central atom is only one and it is attached with the carbonyl groups. That means central atom is one and surrounded by the carbonyls are present. Those are called as the ligands. The central atom is the here D black elements, particularly 3D black elements, nickel tetracyanate. Nickel tetracyanate. Sorry, that is a type of complex compound. Now here carbonyls, instead of cyanates, you are using of the carbonyls. CO4. Okay, nickel tetracarbonyl. This nickel tetracarbonyl is the tetrahedral structure. Hexacarbonyl ferrate. It is octahedral structure. These are called as a monocarbonyls. Only central atom is, that is a metal atom is only one is there, nickel and iron. Suppose there are having of the two metal atoms are there, those are called as bionuclear, okay, biomolecular carbonyls. So you are having of the biomolecular carbonyls. That is about the carbonyls. Next is the silicates. The silicates, again, you know that the silica is already, you know, it is a giant formula. It is a units of the SiO4 minus 2. That means one silica unit, the unit is a SiO4 only. That means the silica is bonded with the 4 carbon atom. That units, how many number of units are attached to that one? On the basis of that one, it is classified into chain silicates, pyrosilicates, sheet silicates, cyclic silicates, and zeolites. These are the 5 categories of the silicates are present that you have to remember and write in the examination. Silicates. Next is silicones. Silicones are nothing but alkyl halides. That means silicon alkyl halides, when you are preparing that one, you are getting of the silicones. These silicones mainly used as a hot water baths. That means these silicones are resistance of the high temperature. They resist the high temperature. That's why using of the water baths treatment and resins preparation, dyes preparation, these are the present in that one. So the silicones are used. This is about the that means the classification. Next, you are having the superphosphate. That you are having of the next question is these are the question which are present in the 4th group elements. Okay. Next, coming to the 5th group elements. The 5th group elements here. Write the electronic configuration of 5th group elements. What are the elements which are present in the 5th group? Nitrogen, phosphorus, arsenic, antimony, bismuth. These are the 5th group elements. Nitrogen, phosphorus, arsenic, antimony, bismuth is the 5th group elements. Those are, you have to write the nitrogen is the 7th element in the periodic table. Write the electronic configuration, you are getting of that one. So next is the, what is the important of electronic after the electronic configuration? Oxy acids of the nitrogen. What are the oxy acids are there? Nitrous acid, nitric acid, okay, pernitric acid, those are the important one. And the next example is main important of preparation of the nitric acid by the Ostwald process. From the Ostwald process, nitric acid preparation is. Next is oxy acids of the phosphorus. So 6 oxy acids are there: hypophosphorus acid, phosphoric acid, okay, orthophosphoric acid, pyrophosphoric acid. Okay, these are the peroxyphosphoric acid. Those are present in that one. You have to write the oxy acids of the phosphorus also. These are important 2 questions are the essay type question. One is the preparation of the nitric acid by the Ostwald process. Next is the oxy acids of the phosphorus. Next is, in this short bit, what is the superphosphate and what is the uses of superphosphate? So superphosphate is nothing but the, when rock phosphate, that means Ca3PO4 taken twice. These are called as a rock phosphate. It is also called as a bone ash. This rock phosphate is crushed into fine powder, and this rock phosphate fine powder is mixed with the concentrated sulfuric acid. When you are mixing with the sulfuric acid and keeping the 3-4 days in a dark place, so fermentation takes place, formation of the superphosphate. This superphosphate is the good manure for the farmers. So it is used as a fertilizer. That is about the superphosphate and its uses. Next is the preparation of hydrazine, N2H4 hydrazine. How to prepare the hydrazine? What is its structure? Next, hydrozoic acid, N3H hydrozoic acid preparation. In that also, we are having of the two questions are what is volumetric analysis, what is gravimetric analysis. That you have to learn that. Okay, this is about the first block. Now coming to the second block, organic chemistry. We are having of the three more chapters in that second block: alkynes, benzenes, arenes. Already we discussed that one already. Okay, just important questions are in this. Write the preparations and properties of acetylene. Already told that alkynes are preparation general properties. The commercial process is when the calcium carbide is hydrolyzed. Calcium carbide is hydrolyzed. You are getting of acetylene gas. Or dehalogenation. Dehydrohalogenation. Dehydrohalogenation means when you are taking of the 1,2-dibromoethane. 1,2-dibromoethane is reacted with the alcoholic potassium hydroxide, excess amount of the alcoholic potassium hydroxide. You are getting of the acetylene gas and potassium chloride, and you are also liberated out the water molecule. 2 moles of the water molecules are liberated out. This is about the dehydrohalogenation. Dehalogenation means tetrahaloalkanes. When the tetrahaloalkanes is reacted with the zinc dust, and tetrahaloalkanes are reacted with the zinc dust, that is a reduction takes place. We are getting of the acetylene gas. That is the methods of preparation. And the properties, we are already properties, general properties, the addition of hydrogen. That is called as a reduction. Addition of hydrogen means unsaturated hydrocarbons. Unsaturated hydrocarbons. When you are treated with the hydrogen, adding of hydrogen in presence of nickel catalyst, formation of alkynes is formed to alkenes, alkenes is formed to alkanes. That is the first method. Next is addition of halogen, addition of hydrogen bromide, addition of water. These are all. Addition of water is very important. When acetylene gas is treated with the water in presence of sulfuric acid, concentrated sulfuric acid containing mercury sulfate, containing the mercury sulfate. So immediately formation of acetaldehyde. Acetaldehyde is formed. That is a very important chemical reaction. That is nothing but the acetylene is hydrolyzed in presence of concentrated sulfuric acid containing mercury sulfate. So here the reaction process takes place, acetaldehyde is formed. Okay. Next is the oxidation. When acetylene is oxidized, oxidation process, we are getting of the oxalic acid. COH, COS, oxalic acid is formed, or H2C2O4. That is a oxalic acid form. This oxalic acid further oxidized, we are getting of the carbon dioxide and water. Okay. And also one more is there. Acetylene is addition of hydrogen cyanide. Acrylonitrile is formed. Cyanide group is attacked on the hydrogen. That means replacing of that acrylonitrile is formed. This is our properties. Okay. Next, uses. What are the uses of this acetylene? Already I told that acetylene is a garlic smell. It is used for the cutting purpose as well as the welding purpose of heavy metals. Cutting and welding purpose. Okay. Next is it is used for the dyes, perfumes, varnishes, and synthetic rubber, preparation of synthetic rubber, and there are also plastics, plastic industry. These are the uses of the acetylene gas. Okay. Now, the last question is in this fourth unit. What is the acidity, alkalinity of acidity of your alkynes are more acidic than the alkanes and alkenes? Why? They are asked. So acidic character of alkynes. Why the acidic character? I already told that the comparison between the alkanes, alkenes, and alkane. When you are taking of the alkanes are undergoing of sp3 hybridization. Alkenes are undergoing sp2, and alkynes are undergoing of sp hybridization. So in this hybridization, the sp3 means the molecules having the 109 degrees 28 minutes tetrahedral structure. sp2 means 120 degrees trigonal planar structure or trigonal pyramidal structure, and sp means 180 degrees linear structure. Okay. So when comparing the s character in the sp3, s character sp3 having of the 25%. In the sp2, s character is you are having of 33%. In the sp hybridization, that means in the acetylene, s character is 50%. When you observe the 25%, 33%, and 50%, gradual increasing is there. So if S character is gradually increases, What happened? They come very closer to the double bond. That means hydrogens, protons are, you can easily replace. That means one protons are eliminated easily, means it act as a acidic character. So hence ethylene group is having of the S character is more. Due to of the more S character, there the mobility of the electrons are very easily to remove that one because of very close to the double bond. That's why the ethylenes or alkynes are more acidic than the alkenes and alkanes. That you have to remember in that acidic character. Okay. Next lesson is fifth lesson, that is the benzene. So what is benzene actually? How the structure of the benzene is present in the chapter is only the important one is the benzene, benzene structure, what is aromatic character, what is Ukel's rule, what is resonance energy. These are the 5 questions repeatedly asking. So benzene is first 1825 Faraday is discovered the benzene from destructive distillation of whale oil. They are getting off. But the Mitscherlich in 1834 Mitscherlich is that means they found that the formula with the help of the molecular weight. Molecular weight of the benzene is 79 grams. Due to the molecular weight and remaining other properties, the benzene formula is invented by the Mitscherlich in 1834. That is C6H6. This is about. And the structure of the benzene in 1864. Okay. In the 1865, it is Kekulé is discovered the structure of benzene. This is about the main important introduction of the benzene. So in that area, what is the aromatic character? Here, when you observe the benzene formula C6H6, it seems to a very unsaturated hydrocarbon. Why? Because saturated means CnHn plus 2. Unsaturated means CnH2n or CnH2n minus 2. Here also the benzene formula is CnHn minus 6. It seems to an unsaturated compound. If a hydrocarbon is unsaturated one, they must undergoing of addition reaction, just like the alkynes. But in this case, benzene does not undergoing of addition reaction. They can undergoing of substitution reaction. Actually, who are going on the substitution reaction? Only saturated hydrocarbons can undergoing of the substitution reaction. Only alkanes are undergoing of substitution reaction. But here benzene also undergoing substitution reaction. So what is happening here means a molecule seems to be unsaturated, but it does not undergoing addition reaction, but it is undergoing of substitution reaction. This phenomenon is called as aromatic character. So benzene showing of aromaticity. Aroma means fragment. Is a good smell. That aroma is present in the benzene. So this can be explained by the Ukel's rule. What is Ukel's rule? 4n plus 2 pi electron system. If any compound can obey the 4n plus 2 pi electron system, that compound is aromatic character. So 4n plus 2 pi electrons means n, you will get the n is integer 1, 2, 3 like that. Not the fraction, not the decimals, only 1, 2, 3. That is the integer you can get. See if it's the benzene. Benzene is having of the structure, 3 double bonds are present, alternative double bonds are present in the benzene ring. That means total in the benzene, 6 pi electrons are present. Those 6 pi electrons are delocalized one. All are delocalized. Hence, these delocalized electrons are, their mobilization takes place. In this case, 4n plus 2 pi electron is equal to 6 pi electrons. When you are comparing the benzene, whether it is aromatic or not, we are seeing up. So 4n plus 2 pi electron means n is equal to 1. N is equal to 1 is an integer means it is a obeying of Ukel's rule. If any compound is obeying of Ukel's rule means it is nothing but a aromatic character. So benzene is aromaticity. That you have to explain. Okay, like that. Other examples are naphthalene, phenanthracene, dirazar, anthracene, naphthalene. These are all are aromatic character only. And also they can explain with the help of Ukel's rules also. 4n plus 2 pi electron system. Okay. Next is Resonance energy. What is resonance energy? If you see the benzene, they are having of alternative three bonds are there. Single bond, double bond, single bond, double bond, single bond, double bond. Like that, three double bonds are there. If you break the double bonds, if you breaking of one bond, the amount of energy required is 28.4 calories of energy is required. So three bonds means 28.4 into 3, you are getting of some value. But experimentally found that the benzene removing of 3 electrons, there are certain value is there. They are giving up the some 74 like that you are getting. Okay, 54 calories, some amount of energy will be required. Experimental calculation as well as the theoretical value calculation, the difference is 36 kilocalories are obtained. This 36 kilocalories of energy is called as resonance energy of benzene. So what is the resonance energy of benzene means 36 kilocalories per mole of energy is required for the dissociation of double bonds. That is called as dissociation, that is resonance energy. Okay, so friends, here three local, that means 5 bonds are present. For removing of that one, you are getting of the some amount of energy. This amount of energy is required. This is resonance energy. So atom will be, the molecule will be, stability is present. So 36 kilocalories. This is about the benzene. Okay, so in the 6th chapter, we are having of only structure of benzene, aromaticity, Huckel's rule, and also resonance energy. These are the important questions from the 5th chapter. Now coming to the 6th chapter, it is arenes. Arenes means nothing but benzene derivatives. Benzene derivatives are called arenes only. That is only. Benzene derivatives are arenes means you are having of the, these benzene is having of alternative double bond and single bond is there. This benzene is undergoing of electrophilic substitution reaction. When any electrophile like nitro, sulfano, halo, these are the, where it is attack means at the ortho position. At ortho position, that particular electrophile will be attacked. That will be explained with the help of electrophilic substitution reaction. General reaction of electrophilic substitution reaction. When the benzene, where it is attacked at the first, at fast reaction, it is electrophile will be attacked at the ortho position. Slowly, the resonance structures will be formation. That means moving of the pi electrons, they are moving into the alternative. They are getting ultimately another resonance structure will be formed. That resonance structure, on that resonance structure, electrophile will be attacked on the ortho position. That you have to remember. This is the first property of electrophilic substitution reaction of benzene. Okay. So on the basis of this general reaction, you can also write the mechanism of nitration, sulfonation, and halogenation. So in the examination, they will ask the write the electrophilic substitution reaction by the nitration. So nitration means what? Nitration mixtures you have to take. What is a nitration mixture? HNO3 and sulfuric acid. HNO3, H2SO4. They are combining. If you are taking off 1:3 ratio, 1:5 ratio, you are getting what? Nitronium ion, hydronium ion, and bisulfate ion is there. This nitronium ion is act as a electrophile. That electrophile will be attacked on the main reaction. Again, the mechanism electrophile. First reaction, this electrophile will be attacked on the ortho position. Next, we are getting off this electrophile will be substituted by the, that means removing of the bond. There is a delocalization takes place by bonds. Then ultimately resonance hybrid getting off. They are getting off nitrobenzene. Nitrobenzene is formed. That resonance structures, that is a mechanism. You have to show the in that electrophilic substitution. Okay. Just like electrophilic substitution, nitration, electrophilic substitution of halogenation. Halogenation what? Chlorine. Chlorine is reacted with the ferric chloride, FeCl. We are getting off chlorine Okay. Chlorine minus and FeCl4. We are getting off that one. That we have to learn that one. Then chlorine is act as an electrophile that will be attacked on the same mechanism. Next is sulfonation. That means sulfuric acid. When excess amount of sulfuric acid is taken, that will be split into hydronium ion and bisulfate ion. That bisulfate ion is attacked as a electrophile. That you have to learn. This is about the electrophilic substitution reaction. Next is Friedel-Crafts reaction. The Friedel-Crafts reaction is very, very important. When alkyl halide, either benzyl halide, you are leaving out. So Friedel-Crafts reaction, Friedel-Crafts alkylation, acylation will be there. When the alkylation means simply Friedel-Crafts reaction, benzene is reacted with the alkyl halide in presence of ferric chloride. You are getting of alkyl benzene. Alkyl benzene means if second of the alkyl group is a methyl group. So when you are taking on methyl group, it is nothing but toluene. Toluene is prepared. That is called as a Friedel-Crafts reaction. So this is about the sixth chapter. Okay. So very, very simple. From this part of that one, you are getting up the almost all 40 marks. Now I covered totally 60 marks out of 80 marks. First block 20, second block 40, means totally 60 marks you have covered out of 80. Next remaining two more blocks are there. Those are the that is derivatives. Derivatives are the halogen derivatives are there, hydroxy derivatives are there. Halogen derivatives and hydroxy derivatives. Next is the ethers are there that you have to take into account. Okay, friends. So I hope you can understand that very easy getting of the good marks from this third sem. Very easy. If you are perfect, completely perfect of the both two black 1 and black 2, simple you are getting of the 60 marks. Simple 60 marks. For about the 20 marks purpose, third black and fourth black they are to take. So third black is consisting of again organic part, halogen derivatives, hydroxy derivatives, and ethers. In that third, that is the last chapter, ether is, you know that preparation of ether by means of the Williamson synthesis. That is compulsory question, Williamson synthesis. Next preparation you have to learn in that case. Okay. That is about the third block. Next, that means it clearly mentioned in the halogen derivatives, hydroxy derivatives. Halogen derivatives, they are having of the, there is a mechanism is there, SN1 mechanism, SN2 mechanism is there. Here the aldehydes and ketones, hydroxy derivatives, alcohols are there. What are the alcohols? We have to learn. Okay. And ethers, ether means simple ROOR. Ethers, the general formula of ROOR is a ether is present. How to prepare, how to getting up the good marks done from that chapter also. You can write tomorrow. That means on the board. Why? Because today I'm not having the board. Okay. So here tomorrow I can explain the hydroxy derivatives, halogen derivatives, and also you are having of the ethers. Next we are having of the fourth black. Fourth black is consisting of inorganic part is there. So fourth black is the inorganic part. In that we are having of the solutions is there, solid state is there. Okay. And phase rule is there. These are the chapters which are having of that one. So solutions, in the solutions they are having of Henry law. Henry law, what is the deviation? And what is Rod's law? What is its application? What is Nernst distribution law and its application? You have to find out that one. So in the solution chapter, we are having of the three important questions are Henry's law, Rod's law, and Ness distribution. Next is we are having a one more question, that is a topic that is 11th chapter, solids. In that solids, the questions are what is isomorphism, what is polymorphism, what is isomorphism, what is polymorphism, what is isomorphism, what is polymorphism, that you have to learn. Next is the what is Bragg's equation? Derive the Bragg's equation. N lambda is equal to d sin theta. N lambda is equal to d sin theta. You have to derive. That is a compulsory question from the solids. Next is the phase rule is there. In the phase rule, we are having of the equation, the phase rule, F is equal C minus P plus 2. F is equal C minus P plus 2. That is a phase rule. F is called as a degree of freedom. C is called as components. Okay. P is called as a phases. How many phases are present in a given equation or given reaction? In that, how many components are present? What is its degree of freedom? That you have to learn in that particularly phase rule. Now, last in that phase rule, we are having of the applications of phase rule is there. Where this phase rule is applied in one component system, in two component system. One component system example is water system and sulfur system, one component system. And two component system is we are having of the two component systems are there. Okay. Add in cadmium, like that two components are there. Okay. So these are the very important questions. The essay type question. Applications of the phase rule. One component system is water system. Sulfur system is a one component one. And two component system is the that also present. Okay. These are the total our third SEM syllabus. So I hope you are understanding what are the important areas which covered in this and how to learn to get the more marks from this third semester. So friends, we are having of third year group element, that means third semester. These are the four blocks. In that four blocks, we can easily get the good marks. Only the thing is that is the fourth block, only the physical part. The physical part consisting of the solids, solutions, solutions, solids, and phase group. In solution, already I told that what is Rod's law, what is Nernst distribution law. Okay. And in the solids, we are having of the polymorphism and homomorphism. Okay. Next, derivation of the Bragg's equation. The Bragg's equation is very important. If you have physics option is also there, that in that you have to learn in the Bragg's equation, that is n lambda is equal to d sin theta. That is also there. N lambda is equal to 2d sin theta is there. You have to derive how the waves will be taken place for the crystal structures present in the solid, that you have to in the solid. In the phase rule, last chapter phase rule means F is equal C minus P plus 2. F is degree of freedom. C is number of components. P is number of phases. Phases means whether it is in that equation, how many number of compounds is having out is in one phase or multiple places, means whether it is solids, liquids, and gases, where it is there. What is the eutectic point? What is a triple point? Eutectic point, triple point are very different is there. The triple point means A sharp end point where the liquid is turned to the vapor or solid turned to the liquid. The sharp point is called as a triple point of that one. If you are taking the water triple point, how much it is there? Water triple point is given. So previously, if you are questioned the multiple choice question, that compulsory the question will be there. Is a one component system. Okay. Next is the sulfur system is there. It is also one component system. Iodine and also cadmium, Ha, hydrogen iodide and cadmium, two component system will be there. That you have to learn in this case. Okay. See, today no one is joined in this session. Only myself and host is there. Of course, it is recorded. It will be telecast later. Okay. Or you keep in the YouTube. You can listen this topic. Okay. As an important, I given today all the chapters important questions. How to write in the examination. So very easy. So getting of good marks. Why? Because already I told that these are the only questions which are asking in the examination point of view. You have to take it. You have to just practice it. First of all, write down your own notes. I given a questions. On that questions, write down your notes. Elaborate that one. You will get the confidence. So if you are writing the answer from your textbook, that's enough for the practice. Next, once you go through that one, you can easily remember in the examination. You can write it. So then you will get the good marks. That is enough for your examination point of view. Okay, friends. Here, this is a very, very important one. Why? Because in my point of view, getting of pass mark is not very, very easy. But getting of 70 marks is also easy if you are follow my instructions. I given the all blocks, all units important questions. Pick up that one. Why? Because anyhow you are having of the choices are there. Section A consisting of the 50% choice is there. Out of 8 questions, you can only write 4 questions out of 8. Section A. And section B, there is an internal choice is there. That means you can write A or B like that. Such a questions are 4 questions are there. Means depending on the blacks, you have to write. And C section, again you are having the 50% question. That means only 2 questions are there. You have to attempt only 1 question. The C section is very important to getting of the marks. It is carries of 20 marks. It is a very essay type, big essay type question. 300 words you have to write. So 300 words means nothing but you have to assume that it is a 3 pages. Each page you are writing the 100 words. Okay. Suppose if you are select like that, so 3 pages the answer is enough. Means here almost all if you see that one as a science student won't count the words or pages here. We want the material. Whether the answer is suitable the given question or not. Irrespective of that one, if anybody writing means won't consider, you will give the 0 only. That's why very precise. According to the question only, you have to write the answer. So remaining whatever the stories, don't write. Why? Because as a science student, you don't have any stories here. Just write the information to get the good marks. What you are having of the idea regarding of that. So I given almost all out of 12 chapters. I given mostly 18 to 20 short bits, short answer questions. From that you have to write the 4 only. And I given hardly 15 to 20 essay type questions. You will get the 8 questions. In that 8 questions, you have to write the only 4 questions. And section C, you are having of 2 questions are there, but those are already I given in that only they will ask. Means 13th and 14th question. 13th and 14th, 13th question is belongs to the black 1 and black 2. 14th question is belongs to the black 3 and black 4. Is a here clear clarification is given. From black 1 and 2, you will get the one essay type question, 13th question. From black 3 and 4, you will get the one more question, that is the 14th question, essay type question. It is a 20 marks. So that friends, be careful while preparation. Maybe chance of some AB type. In that also 13th question, having of the A and B, each carries 10, 10. 14 is also A and B. Sometimes only single question. It is a lengthy question, maybe also there. So that you have to go through that one. Okay. So friends, it is very easy to get the good marks in the third sem. So I hope you can clearly understand this third sem syllabus, and also as the what are the topics I already given clear idea in each and every point in the inorganic, organic and physical part. Tomorrow is we are having one more session, same time from 10:30 to 11:30. We are having one more class. Today, tomorrow we'll discuss the what are the organic part, that is the hydroxy derivatives, halogen derivatives, and ether. I'll give the notes on that one. Okay. Today I will explain all the topics. I covered the 12 units. In the 12 units, each unit we are having of the some questions, important questions. That question, how to write? What are that answer? I given clear information regarding today's. Tomorrow will give, I'll give the notes on that third black. Okay, third black unit tomorrow. I will give the notes tomorrow. Right, friends? Okay, already time up. We'll leave the class.